This is the third lesson in Chapter 8, which covers equations of lines and equations of circles. We're going to focus on equations of lines. And for the most part, this should again be a review of Algebra 1, and we'll kind of put a geometry spin on it towards the end of this. So there's different ways to write the equation of a line. One of the ways to write an equation of a line is to use something called point-slope form. And it's called point-slope because you need a point, and there's infinitely many points on a line, and you need the slope. So we're not too creative with titles in math, and the name or title of this equation tells you everything. So there is point-slope form written out where x1 and y1 are a point. So for example, if you're given a point that a line passes through, let's say negative 3, 1, and you're given the slope of a line, which is negative 5/3, let's say, then we would plug in our y, and notice there's a built-in minus sign in the equation in point-slope form, equals the slope times x, and there'll be a double negative here, so I just make it a positive, just like so. Kind of like you see in the slope formula. Okay, so this would be the equation of a line in point-slope form for the line passing through negative 3, 1 and having a slope of negative 5/3. That's one of the forms that I might ask you to write the equation of a line in. We'll get to graphing lines, and we'll also review a couple other forms for equations of lines. So we're going to graph lines. The first technique is using x and y intercepts. And the way that we do this is we take an equation, this one, which happens to be in a form called standard form. And there's all these directions above that I've skipped over, but feel free to read those. I'm just going to explain them as I go through the problem. And as it says here, you're going to set y equal to 0 and solve for x. And we write it as an ordered pair with 0 as the y part of the ordered pair because we plugged in 0 for y. So for this line, one of the points is 4, 0. Then we'll do the opposite. To find the y-intercept, we set x equal to 0. And we write that as another ordered pair. And we write it as x is 0 and y is 2. And then we graph the line. We need 2 points to determine a line. That was the line postulate, so we have 2 points. It'd be great if we had more, but in this case I don't have more, or I'm not going to bother getting more. Let me fix that line. That was kind of off. There we go. And we'll just call this maybe number 1 for problem 1. Don't get too crazy graphing multiple lines on one set of graph paper. Unless the problem specifically states to graph like 3 or 4 lines, please only do 2 lines per set of axes and label them. Here's another one. This line is in y equals mx plus b form, or slope intercept form. And we can do the same thing with this, where we plug in 0 for y, subtract 2/3 from the other side, multiply both sides by negative 3/2, and we get 3/2 or 1.5 as the x-intercept and 0 as the y part of that x-intercept. We do the same thing for the y-intercept, this time plugging in 0 for x. And there we go, and we'll graph this one, and I'll graph it in maybe a different color in blue. One of the drawbacks to this technique is that we only have 2 points, so if we mess up one of these, then obviously our graph is going to be messed up. So this isn't my favorite way to graph lines unless the problem specifically says I have to graph it this way. Okay, moving down, let's keep going. There's also a technique for graphing lines, and this is probably the most popular way, which is using slope intercept form, where m is the slope and b is the y-intercept. Making sure that you graph b first and making sure that you graph it on the y-axis. And it's recommended that you do 3 points when you're graphing a line, because 2 points are always contained in one line, but 3 points are not necessarily. So it's a great way to check your work. There's some common mistakes. I'll let you read over those. And here's the first one that we're going to graph. This one's already in y equals mx plus b form. So we'll use this as our slope, which can also be written like this, which can also be written like this, meaning you have to decide if you want the negative to be associated with the rise or the run, and my b is -5. So we'll go down to -5, plot a point, and either rise 1 and run 2 to the left, and I was using this one on that case, that slope that I just drew an arrow to, or I could go down 1 and right 2. Either way, and it kind of seems weird to do it both ways, but when I draw this line, it should look like that part of the birdhouse which had negative slope as the roof line, if you like that goofy slope birdhouse idea. Here's another line. In this case, it's not in y equals mx plus b, so we'll get it in y equals mx plus b. You really want to be careful with this basic algebra, because if we do this wrong, then there's no way that our graph's going to be correct. Okay, so in this case, my b is -1 and my slope is 1/2, or maybe some people like to think about it as -1 over -2, because that simplifies down to be the same thing. So -1, there it is, and I'm going to rise 1, run 2 to the right, or go down 1 and left 2. And when I connect this, it should look like the right side of that slope birdhouse, which it does. And I prefer using 3 points just to check my work. Okay. And then the other last example in this sort of group of examples, this one's an important one, you might want to start this one, is how to graph something straight from point slope form without multiplying it out and getting it into y equals mx plus b form, which is possible, but one of the drawbacks to doing that is you sometimes get weird values for b, like fractional values, and that can make it quite hard to graph it. So all I'm going to do is steal the slope, which is given to me, and I'm going to steal the only point that they give me, remembering that x is over here and I have to flip the sign, and y is over here and I have to flip the sign. So there is my point, there's my slope, and now I'm going to plot my point, but this is not my y-intercept. So I'm going to go -2 up 6, so it actually lands over there in quadrant 2. And then I'm going to use my slope of down 3, right 5, or up 3, left 5. There we go. There is my graph for that problem. And definitely go back to this one. You don't want to undo this and put it in y equals mx plus b. It's just not a good idea, even though in theory it should work. Okay, easy lines to graph would be vertical and horizontal lines. So just as a quick review, sometimes these are both the easiest and the hardest because people forget when it's just x equals and there's no y, it's a vertical line because it's going to intersect the x-axis at whatever value or number is whatever value or number x is equal to. Y equals is going to be the other way then. Y equals a number is a horizontal line, which is sort of backwards from what we might first think about this, because we need the line to cross the y-axis at whatever number y is set equal to. Okay, and we'll probably see some of those in some of the coming examples. Down here is a quick refresher of slope-intercept form, looks like this, in standard form, which looks like this, keeping in mind a couple of things, which is that a, b, and c are integers, meaning that you can have no fractions or decimals, and a must be positive. B and c can be negative, but a cannot be negative. So we'll do a couple of these, and I'm also going to leave some of these for you to try, because this lesson is a little bit longer. All the answers will be on Blackboard, so please check them out. On the first one, we're going to find the equation of the line with a slope of -2. and going through this point, and we're going to write it in slope-intercept form, or y equals mx plus b. If you haven't done this in a while, you might write out the equation first, plug in the slope, then carefully plug in your point. It goes y first, then x, and then put it all back together, making certain that you have it in the correct form. And this one was stated to write it in slope-intercept form. Number 7, find the equation of the line with the slope of 1/3 going through the point 6, -2 in point slope form. I really like point slope form. Here it is again in its raw form. And these have 1s next to them because it's just telling you need to actually have values for that. That's your point. So y minus -2, which is going to be y plus 2, equals 1/3 x minus 6. There's my answer. I'm done. It's somewhat impossible, maybe not actually impossible, but really hard to get from y equals mx plus b into point slope. So you really have to just get used to this formula and starting right off with this. And perhaps you saw this in your last math course. Something else that's kind of interesting about point slope, one of the drawbacks is that there's infinitely many ways to write the equation of one line, because you can choose any point that's on the line, and there's infinitely many points on the line. So it can be hard to check your answers with a neighbor because you could have answers that look way different. I'm going to skip 8, let you do that one. That one's almost the same as a previous one. Let's go to 9. Now they give us basically more work to do. They don't give us the slope. So what we're going to do is we're going to find the slope using the slope formula, like so. Again, you really want, easier said than done, you really want to make sure that you don't mess that up. Then you're going to pick a point. It doesn't matter which point. You have 2 choices, and you're going to solve for b. I'll plug in my m, then I'll plug in my y and my x. That's 4, so I'll just subtract it really quick. And here is the equation of my line, and it did say slope-intercept form, which I accomplished. Let's do one that has, or asks us to get it into standard form. This one's also fun because it doesn't give us ordered pairs, and it expects us to remember that an x-intercept is when you set y equal to 0, and a y-intercept is when you set x equal to 0. So you have to create your ordered pairs, and then carefully do your slope formula. For some reason, doing the slope formula here, I kind of find it more challenging because you have the 0 repeating. Got to really be careful here. I don't know what it is about this, but I always find myself messing this up. There we go, positive 2/3. They want us to get it into standard form. And one of the ways that I can kind of expedite this is I notice that this, my y-intercept, is actually my b. So I don't need to solve for it. If I solve for it, I should get the same thing. So now I have this as my equation. Y equals my slope, 2/3, x minus 2. And then I'm going to subtract my 2/3 x from both sides because my goal is to get it into standard form. So I have negative 2/3 x plus y equals negative 2. And I need to clear in order to A, have no fractions, and B, have no negative in front of the x. And I'm going to distribute this through, and I'm going to get 2x minus 3y equals positive 6. This is standard form. ax plus by equals c. When we say plus by, it doesn't mean that this has to actually be a plus. All right, let's try some parallel perpendicular ones, which I think you're familiar with from algebra courses. These are quite famous problems. Got to read the problem carefully to make sure you know if it's parallel or perpendicular. You also want to double check what form they want the equation in. And one of the things I like to do is destroy my b value because I could care less about that. I need to find a new b value. So I'm going to keep my slope the same so that they're parallel. And then I'm going to use my point and plug it in to y equals mx plus b, subtract 3, and find my b, and write the equation of the line carefully, and I'm done. Let's try one that deals with perpendicular. Let's do the one number 13 right below it. Perpendicular means negative reciprocal slope. I'm going to destroy my b value. I'm going to take this and take the negative reciprocal. I'm never going to use this old slope again. I'm done with it. I can throw it in the trash. So now I have an equation which is y equals negative 1/3 x. Actually, I'm going to take that back because it actually says that I want to put this in point slope form. So I'm actually essentially done at this point. Y minus y1 equals m times x minus x1. All I need to do is plug in my facts. So y minus 5 and x plus 1. And there is my final equation. Got ahead of myself there. Let's go to number 14. Find the equation of a line going through 9, negative 3 in parallel to 2x minus 3y equals 3. So this one is not in y equals mx plus b form. So I need to take the time to actually get it into y equals mx plus b, or slope intercept. Okay. And it says parallel, so I'm going to focus on the slope. I'm going to ignore my b, and I'm going to keep the slope the same. I'm going to use the point that the line passes through to solve for b. I'm going to put the slope out front, even though it's not going to make a difference. Make sure your b doesn't look like a 6. That could be bad. And then I'll put it together into y equals 2/3 x minus 9. And it says standard form. So negative 2/3 x plus y equals negative 9. And I'll clear by multiplying by the common denominator. There's only one, and making it negative to get rid of the negative out front. So I end up getting 2x minus 3y equals 27. Okay. Next, we want to find 3 points whose coordinates satisfy the equation, meaning we want to find points that lie on these lines. There's infinitely many answers. The first one's actually so easy, it's hard. It tells you that x equals 3, and essentially that means that this is a vertical line, and the x value has to remain constant, and I can pick anything I want for y. The strangest things. For part B, they want me to find ordered pairs, and this is a more traditional line, although they're both lines. And on a problem like this, I actually like to spend the time to get it into y equals mx plus b form, because essentially what I'm doing is picking values and making a table, because they want me to find 3 points that lie on this line. So I might pick 0, and when I plug that in and number crunch it, I get 0. I'm going to pick things that kind of work nice, like plugging in 4 for x is pretty easy, because 4 times negative 1/4 is negative 1. And then I might pick 8. I can pick anything I want, and that gives me negative 2. So my answers for this one, possible answers of the many answers, are these 3 points. Next, on 16, we want to tell whether the line described by each equation rises to the right, falls to the right, is vertical, or is horizontal. I want to be able to basically picture these without actually graphing them. So x equals looks like this. This is going to be a vertical line. This line, y equals negative x, looks like this because it has negative slope and it falls to the right, meaning it goes down. And this last one, it rises to the right because it has positive slope. Number 17, write the equation of the line that satisfies each of the following conditions. I want a vertical line, which means x equals, and all I'm going to do is steal this, and the equation of the line that's vertical and passes through the given point is x equals 1. For a horizontal line, I'm basically going to do the opposite thing, which is y equals, and I'm just going to steal the y value, and that line should pass through that point and meet the conditions of it being horizontal. I'm going to skip 18 for just a minute. I might actually come back to this one in just a second. Let's keep going. Let's go down. Actually, I'm going to go down to 20, probably the easiest one on this page. Determine the number of simultaneous solutions of the equation. This is a fancy way of saying figure out at how many points these two lines intersect, and I'm also going to find where they intersect. So they're both already in form y equals, so I'm going to set everything else equal to each other, just like that, if that makes sense. Then I'm going to plug it back in. Because in a problem like this, even though it doesn't ask me in this particular problem to find where this solution is, I would also ask you to do this. So that's where the solution is, and it asked originally what is the number of simultaneous solutions. It's 1. So two lines can cross at one point, at 0 points if they're parallel, or at infinitely many points if they're overlapping. Okay, I skipped a couple. I'm now going to go back. I want to find the point M where the diagonals of this quad intersect given these points. And I'm not going to use the midpoint formula like I did previously because I don't know what type of quadrilateral this is. So based on how it's named, AC is a diagonal and BD is a diagonal. So I'm going to find the slope of AC. That's the slope. I'm going to pick a point that this line is going to pass through, and my choices are either A or C. I'm going to pick A because that would be easiest, so y equals 1/2 x plus b, and I'm going to solve for b. I'm going to plug in 0, and 0, and this is obviously why I picked 0, 0. So my first equation, which is the equation of my diagonal, I don't need the 0 there, but I'm going to put it there, is this. Maybe you're kind of understanding where I'm going with this. I'm now going to write the equation of the diagonal BD using points B and D, and I'll do this one in blue. This one's maybe not going to be quite as easy because this one does not have the origin as one of its points. So there's the slope of that diagonal, Then I'm going to pick a point to plug in, and I'm going to use D. And one of the ways to write an equation in y equals mx plus b form is actually to use point slope form. So you could write your equation of your line in point slope form. And maybe you've already started doing this because you're a fan of point slope. And then you can change this into slope intercept by undoing the parentheses, carefully moving the 1 over, like so. I'm still not done. I want to find where these diagonals cross. I want to basically prove where they cross or identify where they cross algebraically. So I'm going to take the two equations of the diagonals and I'm going to set them equal to each other. The nice thing about what I did was that I have these equations with y equals in both cases. So all I need to do is set this and this equal to one another. So 1/2 x equals 1/4 x plus 3. And actually this was, I left off a sign here. This was negative. And this was negative. There we go. Good thing I caught that. All right, now I might clear this by multiplying through by 4. So this is 2x equals negative x plus 12. 3x equals 12. X equals 4. There's the first point where these diagonals cross. And now I need to take this and plug it back into one of my two equations. It looks like this one might be the easiest. So y equals 1/2 times 4, which is 2. So the diagonals, if I can talk, cross at 4, 2. I didn't graph this one. It might be a good one to graph if you want a visual. And now we'll go back to the centroid problem. This is maybe the granddaddy of all of the problems. So I'm going to sketch a picture. This is not actually what probably the triangle looks like if I were to actually graph it, but I just want a visual, and I want a reminder as to what a median is. And I'm going to call this maybe median 1. So a median goes from the opposite vertex to the midpoint of the side across from it. So in order to do this, I'm going to find the midpoint, and I'll just call it MP, of BC, so that I can identify this point. My goal is, if you haven't read the problem, to find the centroid, which is where 3 medians intersect, but I only need to do this for 2 as long as I do it correct the first time through. So for points B and C, I'm going to find the midpoint of that side, which is 2 plus 8 divided by 2 and 4 plus 0 divided by 2. The next thing I'm going to do is I'm going to find the slope of this line. In order to do that, I need to use the 2 points that this line passes through. It passes through the midpoint and through point A. So that's why I like this visual, so that I can see the 2 points that this line passes through that I know. So in order to write the equation of a line, I need to first find the slope. I have the slope now, and I need to pick a point that this line goes through to solve for B. Of my choices, 0, 0, 5, 2, I'm going to pick 0, 0. And here is my first line. Y equals 2/5 x. It's not my final answer because I'm basically doing what I did in problem 19, building equations for two lines and setting them equal to one another. But I will box it so that I can identify where it is, because now I'm going to do all this again for another median. It doesn't matter which one I do it for. I might do it for this one. I don't know why, just because. And I'm going to call this maybe line M2, which is going to go from C to the midpoint of BA. So I'm going to find the midpoint of BA. So I'm just repeating the work I did up at the top. I'm going to focus on these 2 points. It's nice to do this at least because I'm going to use 0, 0, at least for part of this. And that's where the midpoint is. Then the next thing I'm going to do is I'm going to find the slope of M1 using 2 points that this line passes through. So now I'm going to focus my attention on this point, 1, 2, and C. And there's my slope. It looks kind of weird, but it is correct. It's not wrong. Then I'm going to write the equation of my blue line. And I need to use either C or the midpoint as one of the points in my y equals mx plus b formula. So y equals negative 2/7 x plus b. And maybe I'll use 1, 2. I don't know really which one's going to be best. Two is the same as 14/7. So my b value is 16/7. And I'll put it together in y equals negative 2/7 x plus 16/7. All right, and I'm still not done. Last thing is I need to find where these lines cross to find this magic point, the balancing point, the center of gravity called the centroid. Since I have them in y equals mx plus b form, I can just set them equal to one another like this and sort of decide how you want to now approach this. I might clear this, distribute through, and I know that looks wrong, but it's actually correct. So my x value of this point where the medians cross the centroid is 10/3, and I'm going to plug that back in, maybe into this equation to find y. Which is 4/3. And so my point is 10/3, 4/3, and that was the hardest problem that we've encountered. And in the next lesson, we'll be talking about equations of circles, and we'll also maybe tackle, I think there's another problem down here, talking about the circumcenter and the orthocenter. If you want to, you can start to work ahead on those or wait for the next lesson or check Blackboard. Bring questions to class tomorrow if you have any.